Emberfest in person. Nick.
Yeah, good morning, Emberfest. Welcome to Multi-Framework Mashup. I'll show you a little bit of how to make other frameworks work in Ember. First, a quick introduction about myself. I'm Nick Schot, a senior software engineer at Matter. Have been there for 5-6 years now, I think. Normally, I would probably show you some hobbies, but we've been renovating our house for the past 6 months, and it's, apart from writing this talk, literally been taking up all my time. So next up, why this talk? You've probably heard of or are at a company using Ember, potentially thinking about moving to a different framework or even integrating code from another framework. We all love Ember, but it seems like an almost unavoidable topic nowadays. At Matter, we've also been assisting various companies with this challenge. And the aim of this talk is to show some of the available options and problems you may encounter while doing this. And we might stray a little bit too far from the path while doing that. So let's get started. We'll start with a fresh Ember app. We'll use the latest feed-based app blueprint. So we just pnpx Ember CLI latest new multi-framework mashup with the Ember app blueprint. I think that's still up to date, and otherwise Chris will tell me. The frameworks we'll be looking at are Svelte and React. So we'll add the core dependencies for those two frameworks that we'll be using in addition to Ember. Then a quick refresher. Everyone should know this, but let's quickly summarize what a component is again. Here's an example JS component. There's usually a template at the bottom in this case, with some arguments, some state potentially derived, like the full name in this case, and a lifecycle. In this case, we have a constructor and a will destroy hook. That's called when a component is destroyed. These just serve as an example, of course. You usually don't even need them. So looking at the Svelte component, this looks pretty similar, though the syntax is a bit different. We won't find a class here. Our arguments come in through the $props rune. That's what they call their stuff nowadays. The derived rune allows us to declare derived state, and we also have to import onMount to get a little bit of lifecycle if needed. We can return a function that's called when the component is unmounted. There's multiple other lifecycle hooks available for various other purposes, but yeah, we don't really need them here. And then all the way at the bottom, you can find your template code, because in Svelte, the entire thing is the template. Now let's take a look at React. Again, the syntax looks a little bit different, but the same basic pieces are present here. We have our arguments, first name and last name, and some derived state in the form of full name, and a JSX template. We don't get exactly the same lifecycle hooks we have in the other frameworks, but we can use a use effect without any dependencies defined, and it will run once on initialization, and we can return a cleanup function, which is pretty similar to the onMount hook in Svelte. So let's add these components to our app. We'll start with the adding the Ember components into our route/application.gjs routable components. We'll define two tracked properties and pass them into our Ember components. We can see it renders as expected. So now let's add the Svelte component. We'll import it just like JS components to the templates, same way as the Ember components. That doesn't work. Failed to parse source for import analysis, blah, blah, blah. Basically, this is Vite telling us that it doesn't know what these files are. So let's take a look at the Vite website, see if we can find anything. So we can see on the website that there's an official React plugin, but we won't find anything about Svelte here. We will need the React plugin later, so we'll keep that in mind. So then we resort to Google. I could have asked an AI probably, but I'm old-fashioned, I guess. So we'll Google Svelte and Vite, and this basically gives us a link to the Svelte Getting Started docs. So let's take a look there. First section talks about SvelteKit, which is the Svelte framework, but we don't want the full framework set up here. So let's take a look at the alternatives to SvelteKit section, and we'll see that there's a Vite plugin Svelte available. So if we go there, it says it's the official Svelte plugin for Vite. So this is exactly what we need. Let's add it to our project, let Vite rebuild, and we'll also add the official React plugin we saw before. But then nothing renders. We get a component manager error that there's not a component manager associated with the definition. So Ember basically doesn't really know what these components are. We can't just render another framework's components in an Ember template and expect it to work. So what about a custom component manager? Unfortunately, many frameworks, including Svelte and React, compile to function-based components, and the current implementation of component managers rely on class-based components. So I did go into that rabbit hole a little bit with some help of Chris. We didn't quite figure it out yet, and there was time limitations, but we'll leave that for another time. I might dig in more. So what else can we do? We can go back to basics. Let's take a look at the React documentation and see how we should actually use this stuff. So going there, you will find in the React DOM documentation a create root function. And that's a way to mount your React component in a piece of DOM. It takes an element as a target, and within that element, render your React component. Sounds like exactly what we need. In the Svelte documentation, we can find pretty much the same thing. There's a mount function, and if we look at the mount options definitions, we can see that there's a target we can pass as for where to render the component. So what do we need on the Ember side? If you recall the previous slides, APIs to mount components, we need an element to serve as the root, some lifecycle like initial render, updated arguments, and a destructor to clean up when we navigate away from the component. So we need a modifier. For that, we'll install the Ember modifier package, because it provides a convenient API for us to do this. And then we'll create a React bridge.js component, which will serve as our interface between these two frameworks. We can put the modifier inline inside of the GJS file and use it directly in the template. So that's what you can see here. The class at the top is the modifier, with the modify function, element, positional, and named arguments. And then the template below puts the modifier on the div, which will serve as our root element for these frameworks. And as you probably know, this modify function will rerun anytime any of the arguments get updated. So then, as for the implementation of the modifier, on the very first run of this modifier, we need to create the root in our div element. So we have a conditional if this.root, if not this.root, we'll create a root, and we'll register a destructor function to clean it up when the modifier is unrendered. Then after that, we'll need to call create element to turn our JSX, supposedly just JavaScript, into a DOM element. And pass it to the render function of the root we just created to make it renderable in the DOM. This code will rerun every time our modifier receives updated arguments, and React will take care of diffing the changes and updating the DOM. So let's update our original code. Instead of just importing the component and trying to render it directly in the template, we'll pass it to our newly created React Bridge component. We have a component argument and a props argument. So we pass in the imported component and the tracked properties. So then if we look at the result, success, we can finally see some output from our React component. So let's get back to Svelte. This modifier is pretty similar. We use Svelte's mount function to create a root for the Svelte component on the target element and also pass it the props. Then we similarly have to unmount it when the modifier is destroyed. Svelte provides a separate function for that. We pass it the root, and we register that in a destructor again. So one difference here is that Svelte only mounts the component once. There's no way to re-render it again. That might be a problem later, but let's see if the basics work for now. So we'll update our code again. It's basically the same as the React bridge. We pass it the Svelte component and our props. So success again. We now have components from our 3 frameworks. Then let's reflect a little bit, because this interface is not super convenient. Fortunately, Preston made a thing, because of course he did. I decided not to use it for this talk, since it uses slightly more complex API internally, but it's pretty much the same thing. And the end result from Preston's version is nicer to use, so I did want to highlight it. So to use it, we import our React component and wrap it with the make renderable function exported from Preston's library. And this provides us with an Ember component that we can use directly in the template. Internally, the same modifier implementation we saw before is used as an interface between the 2 frameworks. So there's some other options you could consider. As mentioned before, we could maybe find a way to make the component manager work and allow it to handle this transparently for us. That would be quite nice. Or you could think of an AST transform, but I don't think there's too much benefit of using an AST transform over what Preston made. So now let's try to add some reactivity. On the Ember side, we know the modifier we used for the bridge components will rerun when we update the tracked value. So let's see what React and Svelte do. So we add a quick function to our application.js routable component where the tracked state is to flip the first name and last name, simple button that triggers the action. Let's see what happens. Yes, it works. Oh, wait, not for Svelte. We didn't fix the reactivity on the Svelte side yet. The modifier runs when the arguments change, but we never tell Svelte to do anything with the updated arguments. Looking at the Svelte API, we won't find a render call or other function that will help us in the same way React did. We need to approach this slightly differently. We need to use one of the Svelte beams to make the arguments reactive. So let's go back to the Svelte docs again. We'll find a $state rune, which allows us to create reactive states, which means that your UI reacts when it changes. Sounds like just what we need. It's good to know that unlike a tracked property, $state is a deeply reactive state proxy by default. So it's kind of like tracked object, tracked array, etc., all in one. And for us, this means that we can wrap our props object with it directly, and everything inside should be reactive. So let's modify our modifier and wrap our props in a $state rune. Alright. $state rune is only available inside .svelte and .svelte.js/ts files. Of course, doesn't work in a GJS file in that case. So let's visit the link in the error. There's not really anything useful here, but the message itself does give us a hint. It's the same message we got in our browser. So let's go to the .svelte.js and svelte.ts files documentation. Besides Svelte files, Svelte also operates on svelte.js and svelte.ts files. These behave like any other JS or TS module, except that you can use runes. That's exactly what we need. What's important to know here is that Svelte is a compiled framework, and the .svelte extensions are how it knows what files to compile. So there's another snippet of information that's relevant here, and that is that you can declare state in .svelte.js files and pass it across modules, which is effectively what we need to do as well. So we'll create a reactive props.svelte.js file with a reactive props function, and put the $state rune in there and throw in the props. This basically gives us kind of a boxed reactivity. So we can then import that function into our modifier, wrap our props, and yeah, we can do that only once, because otherwise we lose the reference to the $state instance. So when arguments are updated through the modifier, we'll need to manually update the props $state rune with the new arguments. So I wrote a little else section in the code here, which does exactly that. And finally, success. So let's reflect a little bit on reactivity so far. The modifier approach provides us with reactivity at the boundary, so inside of the React bridge, but this doesn't necessarily scale super well, and there's a risk of prop drilling. Of course, it also works for state consumed by the modifier. It also only works for state consumed by the modifier. Most frameworks also provide a way to access states instead, like not just arguments, but also like a global way, a shortcut way. In Ember, we have services. Other frameworks have a context API. But in this case, because the modifier is our only reactive interface, looking up a service or passing down a service into these other frameworks and then interacting with it doesn't make the reactivity work. So what if we do want to integrate or would want to integrate this in a nice way? So there is a TC39 standards proposal you might have heard of called Signals, which aims to provide a standard around reactivity. If this proposal is accepted and adopted by frameworks, we could have a universal reactivity system supported by the browser. Unfortunately, it's not quite there yet. It's still a proposal, and I don't think there's any official browser implementations. So we'll create our own Signal-like decorator. A very simplified version, I will add. So our decorator is called Signal, just to not make it confusing, and has 3 arguments, a target, a property, and a descriptor. And furthermore, it has a getter and a setter. So the value of the signal is in this case stored in a signal.state instance from the official Signal polyfill. This is not strictly necessary, but it provided a convenient shape for me to use. We use the descriptor to look up the initial value for the decorator. Like if you remember, if you set a tracked value, you can assign an initial value, and through this descriptor, you can read that. We'll store that inside of the signals instance, and finally, the getter will need to return the current signals value, which we can retrieve by calling value.get. And then for the setter, it will need to update the internal value of the signal, and it doesn't need to return anything. Next, we'll extend our decorator to work with Ember. We use 3 functions from the Glimmer validator library to integrate with Ember's reactivity system: tag for, consume tag, and dirty tag. We also use this signal instance that we have to create that tag so that Glimmer can keep track of it for us. When we get the value, we will need to call consume tag, and when we set the value, we will need to call dirty tag. This way, Ember can keep track of changes in the reactivity and update the DOM as needed. So let's create a basic counter service with a count value and an increment action that, increments this count value. And we can use our signal decorator instead of the usual tracks. And then we'll update our Ember component to integrate our new service. So we inject the service, we render the count, and add a button to call the increment function. And it works as expected. If we click the button, the count is incremented and Ember re-renders the component. As we learned, this won't work for Schot yet, so we need to do some more work. Schot provides a create subscriber function to integrate with external event-based systems with its reactivity. So let's see if we can use that within our signal decorator. Let's update the getter first. We call create subscriber, which gives us an update function that we need to call whenever we need to tell Schot that the value changed. So we'll store that in a property that we can later access in the setter called notify Schot. What we return is a cleanup function again, so that the subscriber and notify Schot are unset so that they won't be called anymore when Schot has decided that this doesn't need to exist anymore. And then later, similar to consume tag, we need to call the subscribe function we just created in order to start listening to changes. And finally, we update the setter to call the notify Schot function we just stored when the value is changed. Now both Schot and Ember should be aware of changes to our counter, so let's try it. We'll update our Svelte component to receive the counter service as a prop, which we should not forget to pass an argument to the Svelte bridge. The template then looks remarkably similar to the Ember component, just some small syntactic differences. And it works. So then, what about React? I did actually partially integrate React in the demo app that I'll share at the end of the talk, but the implementation is not quite as neat as the Svelte one. And this was also about the time I discovered that Chris Thoburn was wrapping up his warp drive integration for React. And I found it more interesting to put that inside of the talk because, after all, data is a big chunk of what needs to be reactive in your app. So you've probably heard about warp drive by now. It's the Ember data we know and love, but completely reimagined. The main thing that's relevant for this talk is that it provides a signals-based universal reactivity system and has or will have integrations for all major frameworks. We'll hear a lot more about warp drive during upcoming talks, but I'll give a small preview on how it could help us with our problems. I've added a quick Ember Mirage setup to the demo app. No time to explain that, so if you want to know how to do that in a Vita app, take a look at the talk I gave at Ember Europe. You can find it on the Ember Europe YouTube channel. And then for the warp drive setup, I chose to go with the most modern setup, which is, I don't think, fully recommended yet because it's not fully complete, but for the demo it works well enough. So we'll not find any adapters, models, etc. in here. In addition to the core dependencies, I also added warp drive Ember and warp drive React packages for the respective framework integrations. A Svelte integration is also in the works, but wasn't quite ready yet when I prepared this talk. I don't know if Chris maybe released it on the plane, but I don't think so. Finally, we register a schema for a user resource with the first and last name, which is enough to see if the reactivity will work. The store configuration, I think there's a utility function now, but I couldn't use it yet when I tried. So the store configuration is rather large, so I won't show it here. But it's configured for Polaris modes and is an Ember service as per the latest warp drive documentation. And I added a quick update handler so that we're able to persist changes. So warp drive provides reactivity integrations for multiple frameworks. And if you want to use one framework in your app, you can simply add a side effect import for the relevant framework in the entry point of your app. So in the case of an Ember app, that would be the app.js or app.ts file. Adding multiple of these imports, unfortunately, will not work as they will override each other. In order to make this work for both frameworks, we need to manually compose both configurations. So we start by importing the necessary building blocks and the setup signals hook that we can call with our final configuration to make it work. So we'll define a function that composes both configurations. First, we generate a configuration for Ember and then also one for React. We will fill in the return value in a bit. And then lastly, we call setup signals with the configuration function we just created. So now to the actual configuration. The interface warp drive provides us looks like this. There's create signal, notify signal, consume signal, etc. How each of these can be forwarded to the framework-specific configurations differs a bit. So we'll look at a couple of examples. I will not go through the full thing. So let's look at create signal. In this case, the return value is used by notify signal and consume signal, so we can define the return shape ourselves, as we will be the ones using it. So what I do here is I return an object with Ember and React keys, which call the respective configuration create signal functions. Then notify and consume signal call their respective functions with either signal.ember or signal.react as received from the shape we just created. So this should be enough for an example. If you're interested in the full implementation of this configuration, you can check out the source code in the demo app. So what about using it? Let's add a simple example to our Ember component. We'll use the request component and use the find record utility to generate the query to get our user from Ember Mirage. We can add a quick loading state, and once loading is done, the content block will be rendered with our hello from warp drive first name, last name. Then back to React. So to start, we will pass the store instance from Ember as a property to our React component. And then we need to pass that store instance to the store provider, which is part of the React integration that WarpDrive provides. This makes the store available within the React app, so the request component knows where to find things. We can then also use the request component within that store provider in basically the same way it works in Ember to load the records. So if we now visit the page, we should see both components requesting and rendering the user, but only one request should be made. WarpDrive will deduplicate multiple requests to the same resource. So let's update the record now to see if the reactivity actually works. So on the Ember component, we'll add a button that will call this shuffle mirage function that I wrote. We look up our user record, which in Polaris mode is immutable. So we need to check out a copy of this, which is editable. We update the first name and last name properties with the opposite because we shuffle them again. And then we call store.request with the update record method to persist the change. If we now click the shuffle button, we should see the user being updated in both components. And it works. So this brings us to the end of the talk. So let's go over what we learned. Turns out at the core, it's not super difficult to render other frameworks' components. Reactivity is a bit tricky, and we'll either have to integrate systems with quite a bit of hackery or adopt some kind of universal reactivity system. And finally, WarpDrive really delivered because this was way simpler than I expected it to be. And was also just in time for this talk, at least after I asked Chris to publish the packages. And well, overall, I can say I'm very excited about where it's going with WarpDrive. That being said, we've only seen some of the concerns you'll run into when trying to integrate multiple frameworks. Testing is definitely not one to forget, with many potential pitfalls around timing, event handling, and more. Routing is another one that's not quite straightforward once you start including complex component hierarchies written in another framework, and you'll have to think about how you deal with that. So hopefully this talk was insightful. The demo app is available on that GitHub link. I'll also post it in the Discord if people are interested. If you run into any of these problems or have questions around these topics, feel free to reach out to any of us at Main Matter during or after the conf, of course. And I'm also interested in your own experiences on these topics. So thanks.
Thank you, Nick. And if you do have any questions right now, okay, there we go. We have time. But Chris, you can already come up and we'll get you set up right away.
Thanks, Nick. What about bundle size? If you're building an application that's using Ember and React and Svelte, does the final bundle size gets a lot bigger because you integrate all those frameworks?
Yeah, I mean, it becomes bigger because you include the extra framework, of course. But with Vite, it should be less of a concern probably, especially if you start utilizing dynamic imports to import these bigger chunks of code.
Okay, it should import only the necessary stuff.
Yeah,
I guess. And obviously, without Vite, all you've presented is unavailable. If we're only building with the classic build, without Vite, I mean.
You can also get it to work with the classic build, but I just showed the latest and greatest, of course.
Okay, thanks a lot.
Webpack might make things a little bit trickier sometimes, but it should work, yes.
Thanks again, Nick. Give him another big round of applause, please. Thanks for kicking us off.